So the recording has been started. Okay. Please let me know when you can see my screen.
Yes, it's visible.
Okay. So we are doing 2 mediums and 1 hard question, and I might have to leave at 9:30 if somebody from my team pings me, because we have some issues going on. So I might leave at 9:30. So
Okay.
okay. So the question says is given a sorted array nums, remove the duplicates in place, and then duplicates appeared. Then such that duplicates appeared at most twice, and return the length. And the thing is, we have to do by modifying the input array in place and without any extra memory. So basically, if my input is like this, then how it should look like. Basically, I should have 2 1s. Then I can't have 3 1s. I can have max 2 1s, then 2 2s, and 3. And if there is anything at the end, it could be there. But I have to return this length. Is the question clear?
So you have to modify the incoming array also, right?
Yeah, we can modify, but we have to give the. So the question says I can modify the incoming array, but I can modify, but I should not take any extra memory.
Okay, go ahead.
And also should do in order of.
Yeah, the question itself says that you must modify that.
Yeah.
Okay.
And with the. Okay, it does not say order of n, but yeah, that should be the best case for us. So how to approach this problem? So basically, I think before doing this, there is one easy question also around that, where there is no constraint of having twice, at most twice. Here it says if I have 1 1 2, I should have 1 2. If I have 0 1 1 2, I should have 0 1 2 3 4. That should be my answer.
Oh, so this is without duplicates.
Without taking a threshold which will say twice, thrice, or 4 times. So any ideas around that? Like we can either solve this first or this first, because both are kind of similar. If we get an intuition about this, then it's easy to solve the other one also.
Maybe we can hi.
Mm-hmm.
So is this the right idea? Like have first the counter of the current integer, and then when it passes, for example, in this case 2, then we save that space, and then for the next integers we'll just replace that, and then increment the kind of like empty space where you can put elements.
So when you say empty space, like how will you define the empty space?
Empty space is just like it's going to be a pointer to that index. It's not going to be actual empty space, but space where we actually have to replace integer.
So are you suggesting something like a 2-pointer approach?
No. I'm suggesting having like for example, okay, 1 1, and then that means when it comes to 2, the duplicates wasn't more than 2, so we just continue. Now the current value is 2. So once we get to the third 2, then we set this another integer, which is going to be the value of the index, where now when we continue the array, we're just going to replace that and then increment the.
Okay, I would like to pause for a second. because how I understood first solving this, let's talk a little bit about if you don't have a constraint of duplicates, how we will do that.
So you just store one number as a something like a previous number,
Okay.
and just store that in the first location of the array. So next time when you iterate through the whole array, you just find out if that previous number is there. If it is not there, then only you store and increment the index, or else just skip it.
Okay. So
Yeah, it was kind of like a explain
Yeah,
it.
but yeah, we can use the, I mean, we can use the thing that is given, like it is already sorted, right? So we can save on space, like we can use two-pointer approach
Yeah, it
to
is a
make sure
two-pointer approach almost. Yeah, but
okay.
duplicate,
So
we will
what?
keep checking if it is same as previous element, then we will increment j, not I, like that, I mean.
correct.
So what I'm hearing, there will be a pointer one, which would be pointing what, 0 or -1.
Yeah, maybe. Yeah, that's true. Yeah.
Then we'll have a pointer 2, which will, let's say if I have a pointer 2 which is starting from 1. So when I say, let's also, okay, we'll put 0, 1, 2, 3, 4. Okay, so these are the indexes.
Yep.
So right now, so if I don't have a constraint of duplicates, what should I do? Like
First, I will set something like a variable called previous, and then I will set that value of that previous to the 0th value.
okay, so this is a previous, which is pointing to 0.
Okay.
So
I was thinking of storing the value, actual value of the previous, not the pointer.
But I can always go like array of 0 to get
Okay. Yeah, makes sense. Yeah.
And now I have a pointer which is pointing to 1. So I think what you are suggesting, like compare with the previous one.
Yep.
So they both are same. So don't do anything.
Absolutely, yeah. Don't increment the p pointer.
Okay, so then I have a 2 which is different from this guy. So that time I need to take some action.
Right. So you need to copy that into the previous and then increment the previous count.
No, I think first I need to increment
First increment and then.
Absolutely. Okay. Yeah.
Yeah. So right now my pointer is at 2, and then I put it here at 2 here. Then I proceed further. So this and this are same. So I don't care. My pointer become 3. They are also same. My pointer become 4. They are also same. My pointer become 5. So this is different from what I have seen the last time. So I will increment my previous to 2 and bring 3 here, correct?
Yep.
Then my pointer will become 6. Then my pointer will become 7. When my pointer will become 8. This is again different. I will increment my previous and then put it here. And then my pointer will become 9, which is again same. So I don't need to do anything. And my answer would be here, this one. The total length would be, answer would
3 plus 1.
Yeah, answer would be 3 plus 1. So basically, whatever I have seen the previous. Is that clear?
Yes.
Okay. Now this is like without having a constraint of duplicates. Now if I tell, I can have a threshold value of 2, 3, 4 or k. It depends. It can be anything. Let me again put it like this. Okay. So what I can do different here now? from the
We
previous
can
one.
just have a counter,
Okay.
like
So
how
that,
many times we have seen one, or like, and every time we see a different value, we reset the counter.
okay. So I have a counter, which is 1 right now. So basically what I'm saying, I will, if you see, if you see in that way, if I can do the same algorithm which we did in the previous one. Here, the another catch is, it can happen till my counter does not hit the threshold value. For example, let's see this. So, so right now 1 does not, 1 and 1, they does not match, but my counter is 1. So I can still go with the same algorithm because of whatever I was trying to put back. So my previous will become 1 here, and I will put 1 at 1 only,
And increment to counter.
and my counter will become 2. Now this guy does not match with the previous. This guy matched with the previous, but my counter also became 2. So this time I should not be doing anything here. Then this and this does not match. So basically I need to do something here now. My counter is already at its max value. Now I have to take some action. So if I make my, so this pointer was at 3. So this guy was at, this will become 2, and I will bring 2 here and make my counter as 1 again. After that, pointer 3 will become 4. So counter 2 is again, counter is again less than 2. So I can do the same process again. Basically, I can make my previous 3 and replace this 4 to here, which is already there. So basically 2 will came to 2 here, and counter will also become 2 here. Then pointer 5, it will become 5. Then, but my counter is already 2, so that means I can't take any action, and it is same what was I have seen previous. So I'll go ahead and make my pointer as 6. Now there's a difference between 3 and what I've seen in the previous. So it's time to increase my previous to 4 and bring 3 here. And oh, sorry, I forgot to reset the counter also. Yeah. And next time what will happen? Previous and so pointer will become 7. They are not different, but counter is 1. I can still make my previous as 5 and bring this guy here at 3 and make my counter 2. Then I got my next is 8. They themselves are different from the previous one. So I'll make my previous as 6 and counter will become 1. And here I will bring 4. Then previous and this will become 9. Previous and they are same, but counter is less than 1. I can still go ahead and do the same operation, which becomes 7, and do a replacement here, which will become 4. And that's how I achieved my purpose. So answer would be 7 plus 1. So here what we did, same as previous algorithm, but we took something like a counter. If my counter is less than the threshold, I should keep on doing that swap or replace operation. Is that clear, or shall I show the code? Then it will be more clear.
Yeah, I think this is clear, at least to me. Yeah.
Okay.
And actually you said it very well, because if the threshold, you can put any number there and then you can solve a lot of problems there.
Yeah, so it could be 2, it could be 3, it could be 4. We can take in that way.
Yep.
I can show the code as well. So code is gone. Oh, because of this. Okay, so I can, so what I was mentioning was, let's say K, here is 2, and then anything can go till K. That's what I was trying to tell. So what it is similar to, so basically I've seen in these kind of questions where you take 2 pointers. There are other questions like where you want to move zeros to the end or move all the zeros to the start. There are some kind of questions which have a similar pattern of taking 2 pointers, and we have to find a condition where I want to take a decision. For example, in this case, let's assume like my K right now is just 1 only. So this will become the easy problem. So basically I'm taking a decision when they both are not same. I'm taking some decision and incrementing my first pointer, which was I. So I will suggest, like, if you want to do this kind of question, think about what kind of condition you want to play. There are questions where this could be like, I want to do like 2 pointers should have something similar, or it could be like they could have something different. So the trigger point could be like, find the condition where you want to increment your other pointer, and so it will yield you in a result. I know, like the question where we have to move zeros and other things, which also has something similar condition. Which condition you want to try? Whether you are seeing a 0, you want to try that, or you are don't seeing a 0, you want to try that. So I'm just giving some idea like how I interpret these kind of questions. Like what condition you want to try here. So in this case, in coming back to this question where K is equal to 2, and if you see, we have 2 conditions here. Either they are not same, or my count is less than K. I should be doing this operation. And in between, if they are not same, just reset my counter to 1, or keep on increasing the counter. At any point where the counter will become 3, we won't come inside this loop unless these J and I become different. It can become 4, 5, but we will never come inside that. We will only come inside this if block if J and I are different or the count is less than K. We keep on doing this replace operation, what is we have seen here. Any questions? I would happy to answer any queries or questions.
What will happen if input is empty array?
Yeah, so if input is empty, then I think just return 0. Or I think in this case, we have to check with the interviewer, like you want to throw an exception or just return 0. So if you see in this case, yeah, so we have to just return 0 or something like that. It could be extra check here. So it's just
Also, outside the if condition, where we have the for loop, do we need to reset the count to 1?
we are doing here.
So, but say if it goes in the else part and now the count becomes 2, and it comes out and it goes in the for loop, right?
Yeah, but
So,
it won't come inside the if loop.
Because they have changed. Okay.
So for example, if I have input like this, so what will happen as soon the count will become 3, we won't come inside this if block. And we'll only come inside this if block when we'll hit 2. And then that time we have to bring 2 here. So basically, I'm keep on doing this replace operation. Either they are different, or if I have not met my count to the k value or the threshold value. So, so basically what I'm doing, here the count will become 2. I will put 1 over here only. If you see, here the count will become 3, nothing will happen. Here the count will become, already it's 3, nothing will happen. Here it is 2. So it's time to, and 2 and this guy are different, which we have done something previously. So 2 will come here.
Okay.
And counter for 2 will become 1.
Gotcha.
So here the counter is again less than 2. We come inside, count will become 2. And then we put this guy also here. What we have seen, next to what we have seen last time. And in the same way, 3 and this guy are different. We just put 3 here. And this we don't care.
Okay. Okay. Thank you.
Okay, so I is the write index and J is the read index. Is that right?
I is the pointer, left pointer. J is the running pointer.
So you only write to the I index.
Yeah, I write to the previous what we have seen previous. You can say is like we can even see it's what we have seen previous. And but the trick is like we have to put it next to that. So we'll do previous plus plus. And then everywhere I have to replace to previous. So I think putting previous is a better. Somebody has suggested as a previous name, which makes more sense to explain.
Yeah, I mean, to me, what just Amazing Learn explained that to me, it's read and write point name.
So I would do something like this. So it becomes simplified. So I want to put next to that and then make previous equal to previous plus plus. So what you have seen previous, I want to put it next to that. Okay. So if you don't have any questions, we can then move ahead.
Yeah, I think so.
Emily, you want to share?
Okay, I'll share my screen. Yeah, could you see my screen? Oh, no. Yeah, let me see. Yeah. It's a question 713. Could you see my screen now?
Yes.
Oh, okay. Yeah. This question is given a number array, and the requirement is to count and print the numbers of contiguous subarray while the product of all element in the subarray is less than k. So the function is given the array and the product k. That means in this array, we have several different subarray, but the subarray's product will not larger than the k, is less than the k. For example, there is an example 1. The numbers, the array has 10, 5, 2, 6, 4 elements here, and the k is 100. Yeah, I will show 10, 5, 2, 6, and the k is 100. That means the subarray, the product of subarray will be less than 100. Let me try. We can first choose the first element. If we only choose one element, the product is 10. If we choose 2 elements, 10, 5 here, we can get 50. If we choose 10, 5, 2, we can get the 100 here. But the requirement is less than k, so we cannot choose 10, 5, 2 altogether. But we can choose the, I can do this. We choose 10 is 10. We choose 10, 5. The product is 15. And we choose, we cannot choose 10, 5, 2, so we can choose 5, 2. We get the 10. We choose 5, 2, 6. We get the 60. We can choose 2. Yeah. Here, maybe we can choose only 5. The product is 5. And we choose 2. Here is 2. Choose 2, 6. The product is 12. And I think I need one more. Yes, 10, 5. It's not 5, 5, 2, 6. Oh, we can choose
only 6.
Yeah. Okay. Yeah. So this 8 subarray, the number of the subarray can meet the requirement is 8. There are 8 subarray, and the product of these subarrays are all less than k. So I have this idea. That is first my idea is to use the 2 point a little bit similar to the previous question, and use the pointer. I can get the product of all the subarray. Let me show you my approach. At first, the left point I is pointed to the first element 10. This is the 10 is pre-product. The pre-product is to product all items before J. J is the index to iterate the whole array. Yeah. First of all, the ij is both of them point to the 10. So the pre-product is 10. And that means we can choose 10 because 10 is less than 100. And when we put the j forward and the j point to the 5 and the I is still point to the 10, the pre-product of this subarray is 50. And the 50 is also less than 100, and we can pick it. So the result, when we pick one element, the result is 1. And when we pick the j is 2, the number is 1 plus 2. That is the result plus the j minus the I plus 1. This means the length of the subarray.
The current subarray, right? The length of the current subarray. Okay.
Yeah. For this situation, we choose 2 elements as a subarray, 10 and 5, and we have the length of 2. So we end up the length to the previous result. The result is the value we want to get for this function. Now the j points to the 2. And we got the 100 here. Because the 100 is not less than 100. So in this time, I have to divide it. The pre-product, if the pre-product is larger or equal to k, I have to divide the product by the nums I. That means we have to move the left pointer right. I'll put this right. So this subarray is only have 2 elements instead of 3. At this situation, the pre-product becomes to 10. And the length of this subarray is 2. So we sum up 2 here. And then we can move forward to j. Now the subarray pre-product is 60. And 60 is less than 100. And the length is 3. So I end up 3 here. And finally, we got the 8. My idea is to use the 2 point, and 1 point j is iterate the whole array, and the I is the left pointer. The left pointer is to move, stay or move right to keep the pre-product less than k. And each time you calculate the length of the array and end up the length of subarray, and you can get the final result. I'm not sure I explained clearly.
I think it is good. So we are trying to say the slow pointer will move only when your pre-product is more than or equal to 100, right? Or else it's not going to move. Okay.
Yeah.
Okay.
So I will say, like, think in that way, again, like Emily said, 2 pointer and a sliding window. When you want to move your window, when you move past the threshold value.
The k is the threshold value. If the pre-product is less than threshold value, I put the J, move forward, iterate
Yeah.
array. But when the product is larger or equal than the threshold value, I move the left point right and divided the pre-product value by.
You're just removing the last value you have seen from your pre-product, and then you move your I, correct?
Yeah, I keep move the right value. Once the pre-product is larger or equal than K, I divided the pre-product value.
Yeah.
Yeah. Here.
And you will keep on dividing it till it becomes less than threshold, right?
Yes, it's a while. It's not the if. Yeah, you're correct. Yeah.
So basically, I think this is something like a standard. I think this is something like a standard sliding window.
Yeah.
When you reach, when your window has come up with some other kind, when your window property has exceeded your threshold, you want to bring it back the window into the regular size or regular window what is allowed. So I think this is like being used in a couple of other problems also, where you want to find something like all palindrome, target palindrome, and yeah, you have given a big string, and then you have a big source, and you have a target, and you want to find where the palindrome lies. So there are different questions. Use the same kind of technique.
Yeah, it's the sliding window is a kind of 2-point. Yeah, you have the 1 point to iterate the whole array, and the left point is always to keep your window under the threshold.
Yeah, and there could be there could be different properties of this window based on different question.
Yeah.
Somewhere it could be like the size of your. It could be actually the size length, or in this case, it is like the product.
Yeah. Yeah. Oh, I can show my code to. Yeah. Yeah. The n is the length of the array, and I have the product initialized to 1, and the left point is 0 index. Result is 0 now, and I use the J to iterate the whole array from 0 to n, and the product is to times all the elements in that array. If the product is larger than K, I divide it by the numbers I, and at the same time I put the I forward, move to the right 1 step, and to keep the product is less than K. Yeah.
Do you think in any case your I will go beyond your J?
Beyond my J?
At line 9?
Yeah.
Yeah, at line 9, do you need this condition I less than equal to J? I don't think so. I will ever go.
Oh, you mean I can omit that condition?
Yes.
Yeah, I'll try. Yeah. Yeah. Maybe some corner cases, if the K is 1 or 2, it's very small.
But it is controlled from your I.
Yeah, I just keep the length is not negative or 0, because I increment the I continuously to keep the product.
So I will say, like, these kind of questions you might end up with the interviewer, where the interviewer asks, like, do you need that check? Because it was asked to me in some similar question, not in this question, but some different question. And I don't think so you need that condition, because your I will never go beyond your j. Because I will always be behind j.
Yeah, my thought is to keep the I as the left pointer, but I'm not sure when the I increase by 1, maybe it will precede the j or equal the j. I'm not sure, so
you can try without doing
yeah, I'll try.
Okay,
yeah.
Sure. So the tricky part was, I think, to find that j minus I plus 1.
Yeah, this is the length of your subarray.
But I want, and basically what we are doing here is we have already accounted single element before. Basically, we have to come up with this calculation. If you see, the answer is 10, 5, 2, 6, 10, 5. So so in this question, we don't need the answer. We just need the count.
Yes.
And I think that's sort of like your calculation actually worked. And I think that is a good way to find out this thing.
Yeah, if you need the each subarray, maybe this method doesn't work.
That case, this question. So I'm trying to bring that point here. We don't need to return all the subsets. We just need the count. So we have to think in that way, how a simple calculation like Emily did j minus I plus 1 could lead me to that. So if I have to print all individual thing, then it would become little different question, could be more trickier. But here it's just a count. So by doing some simple maths, I can figure it out.
Yes, you are correct. Yeah. This question is only needs the number of the subarray, so I can end up the length of subarray. Yeah. If you want the all subarray as a result, maybe it doesn't work here. Yeah.
I think result is really interesting. Can you scroll down? I think the way those things were coming up. Okay. Yeah. So I think the first result you have is for 10.
Yeah.
And the second result you have plus 2 is for 5 and 10 and 5.
Yes, there's 2. Yeah.
Okay.
The one is the previous result here.
Yep.
And I keep end
two,
up the length of
the 2 you added it is for 5 and 10 and 5.
Yeah, the 2 is for 10, 5, the length of the subarray. This is for 10 only, because the subarrays is only have 10 one element.
Okay, the way, maybe I need to interpret the code a little more, but the way I'm assuming the second 2 is for 10 and 5 and 5.
Yes, 10 and 5 and 5. So that's what I was telling you, how the calculation is drive is tricky.
Yeah.
Like
I also have this idea because for example, the 8 is come from like the 8 different subarray, and for example, they have 4 one-element subarray and 3 two-element subarray and 1 three-element subarray. Yeah, it is correct. But in my approach, I didn't count in that way. I just think the first example, they have one length of subarray is only 10, but the second situation, we have 2 elements here. Why we put the 2?
So basically you did 1 plus 2.
Created 1, because in this situation, I have the 5 and 10, 5. The subarray has the 5 and 10, 5. 2 subarray here.
And
yeah, the first situation we have the 10 only, and this situation we have 5 and 10, 5, and in the third example, the subarray has 10 and 2. So we have the oh, okay.
So let's say if you have just 2 numbers and I want to do all kind of permutations out of it, what would be my formula? So basically, I think here we're doing something like a permutation formula. That's what I'm getting a feeling.
Can I add something here, guys? Simple thing. So at any point of time, suppose you are like, you found the rightmost guy, a new guy, for example. Like, for example, I found in this particular example, instead of 10, 5, 2, if it was suppose 9, 5, 2, and I just came to 2, right? 2 is the new guy. So 2 can stand by itself, right? Yeah. That is a valid combination. I can combine it with the previous element 5 to make another combination, right? So 5, 2 can give me another solution. And then if there was 9 also, for example, then I can combine 9, 5, 2 also, right? So you are building this window with this new element every time. So that's why you are always adding the window size. In each iteration, when you are doing j minus I plus 1, you are adding that window size. And why it will not double count? Because you started a new element as part of that window, the rightmost guy. Does that make sense?
Yeah. That's the reason why end up the result each time by the length of the array, because each length extends the different number of the subarray.
Exactly. So that's not magical. That is, if you draw it, you will figure that out.
Okay. Should I move to the next question? Okay.
Yeah. If there are no questions, then let's move. Okay, can you see my screen?
Yes.
Okay, so I didn't get much time to spend on this, and it seems like this question has a lot of conditions, and on top of it, different languages can solve this question in different way. So that was my interpretation from looking this guy. So let's make this. So we'll see if we can able to get some basic understanding on this question. And Emily, if you have thoughts, you can also share. I think you also solved this question, right?
Yes, I solved it by use C++ and use the STL upper bound. Yeah.
Yeah. So that's what I was telling, like every language could have a different way to interpret this thing. Java has something different, and C++, Python, or could be. But let's see what is the problem right now here. It says like, so range module is a module tracks range of numbers. Your task is design and implement the following interface in an efficient manner. So it is telling like you have to do like in an efficient manner. And it says like add the half open interval. So when you do, it will add and tracking every real number in that interval. Adding an interval that partially overlaps was currently tagged. Numbers should add any numbers in that interval, left, right, that are not already tracked. So basically we have to track all the numbers between left and right. And if I try to query something, it returns true if and only if every real number in the interval left and right is currently being tracked. And if I remove, it should make adjustments based on that. So I think let's take an example where I will create some kind of a map where I have a start and end. So in this case, when my map is empty, when I do add range, the first operation, so when I do add range, what will happen? So I have start 10 and end as 20. And when somebody asks me to remove a range, now I have to make adjustments. So I need to remove something like 14 to 16 over here. So what should I do to make that adjustment?
Actually update that end with 14 because we don't want it's an open window. So 10 to 14.
Yes.
And add another range from 16 to 20.
Yes. So then it will split like this. Then let's say, then I'm doing a query range, which says 10 to 14. And where 14 is not being tracked. So basically I will get true because I have something 10 to 14 and I track all real numbers between 10 to 14. Then I get query range of 13 to 15. So I track 13, which is here, but 15 is not tracked. Or like they also said like 14.03, 14, that should also be considered in this case. So I don't have 14.1 or something, which is still 15. So I'll return false here. That makes sense? Then I got 16 to 17. Everything between 16 to 17 is tracked here. So in this way, I got true. Let's assume I do one more add range function, which is, let's say I am doing one more add range function, which is from 13 to 17. So what will happen here?
It will be like a range 10 to 20.
Yeah, so it will again go back from 10 to 20. So basically now my range is 10 to 20 and anything which we have seen earlier should be gone. It will become a flat range. Is that point clear?
Yeah, so you're merging it again, right? So
yeah, we are merging.
Whenever there is an overlap, you try to merge it.
Initially we were, so there are different things we are doing. We are doing kind of, we are either inserting interval or we are just merging them if it is an add operation. Either we are inserting it or we are merging few things here and there. Merging could be with upper and or lower or between both of them. When I say like it could, so in this case, we merged everything as one only, or it could be only merged with 1014, or it could be merged with 1620, or it could merge, or it could be a separate new insertion. For example, if I say add something like 22 to 25, so it will be a separate insertion. It won't do any merge. It will be just a insert interval. What else? So, and what we are doing in remove. So basically, we are doing
before going to remove. Just one thing. So if the range, I know this won't be the case. Like if the range, the start and end were the same. Like in this case, if it is 14, 14. So what would we do?
So let's say we have
add range 14, 14.
14. 14. I think this won't be a valid input then. Or
okay. So we just ignore it.
Yeah, we are
I think we
starting.
should add one element in a range, isn't it?
Yeah, I'm
Only
saying
14 we want to track.
because it's not specifically saying anywhere in the question. So
It might, let's see.
But by definition, this should be invalid input, as the start should include and end should not include.
Yeah.
okay,
Okay, yeah.
we just ignore it.
Okay, so when we remove, we are doing kind of like a split. We're kind of doing a split interval, or it's just a remove if it is not. So basically, we are doing different operations here, and that's what I was telling. This kind of problem, doing. Where I always want some kind of upper bound or a lower bound. This could be done easily if we have something like a language specific help. For example, in Java, there is something like a tree map where I can easily see what is my floor key or a seal key. So, for example, earlier I was telling, like, I have let's say I have an add range of 13 to 17. I can easily check in Java tree map what is lower than 13, which is 10. So I know 13 should be in between 10 and 14. Then I also know in Java I can say what is my upper, like, or the seal key, which is 16. I know 17 belongs to 16 or 20, which is an AND. So basically I have to merge these two guys as one interval. And I think the same thing Emily was also telling, that in C++ there is a way to find the upper bounds, or I think even lower bounds. Is that clear? Then we'll proceed further.
Yes.
I know this is confusing. Even it took for me a while to understand what's going on, because there are too many operations which are happening.
So in the lower bound, like if we are actually looking for 13, so what it will do is it will try to find the start value which is equal to 13 or greater than 13. So then it will stop at that.
So let's say we are inserting 13 and 14. What would have happened here? Nothing. It would have merged between 13 and 14. Let's say I was doing this. What would have happened? Nothing, because already it is part of 10 and 14.
Correct, yeah.
What if I was doing 13 and 15? Then I would take a max of, I got to know where it should be. It should be here. Because when I checked what is the lower key to 13, which was 10. And what is the AND of 10 is 14. And my AND is greater than that. So definitely it should be here. So this will become 15. Correct?
Yes.
So, and other cases, I was having this one, like 17. I know 13 falls between this guy, and 14 is also less than 17. But I also want to check other thing. What is my upper bound to 13, which is 16? Does my AND lies after 16? Yes. So that means everything should go away and this should become 20. So different conditions we have to try here based on how we want to merge things. And doing something like a tree map in Java immediately give what is your lower, because everything is sorted in tree map. So if I get, let's clear this map. If I got something like 13, 17, it would be like this. Then let's say if I get something like 1 and 5, how it insert? It insert in the sorted order. It will put 1 and 5. And at any point I can find, if I have something like 8, 8 or 10, I can immediately find what is lesser than 8 and what is higher than 8 in the tree map. Or we have to do some kind of a binary. So tree map internally in Java is a binary search tree. Or it's as good as we are implementing our own version of binary search tree, where I can see what is my previous element and what is my next element. Does that make sense?
Yeah, I think so. Yeah.
So if anyone, again, that's what I was mentioning, that this, if I do using Java, it would have a different implementation. If I'm doing C++, it would have different. If I'm doing Python, I've seen the discuss, people have written Python code in just 6 lines also. But it was like an alien language for me. Like what happened in these 6 lines, I don't know. But if you see something like a bisect being used, I think bisect in Python is again something which keeps thing in sorted order. And I can also show you this. This will explain the same thing what I just explained. Floor key will give you the start. If your left is 8 and if you have something in your map is 5, it will give you the previous one. Floor is like previous one. And even for the end also he's trying to find the floor key, and then he's trying different combinations like what we have just discussed. And then this part, he's also cleaning up. So if some things got merged, we want to also do some kind of cleanup. So that's what he's doing here. Query range would be simple. But again, the remove range, we have to merge or we have to split things. So that's what he's doing here. And I don't know this kind of questions would be asked in a real interview or not. If you see, there's only 43,000, only like 16,000 got accepted. So for me, it looks like this is not like a popular question to be asked. Unless you know very specific of the language, how you can quickly do this thing. Or I think giving an idea would also be enough for this question if I have to do in a real interview. But if somebody has a better idea, like please feel free to share. Emily, you want to add something here?
Yeah, I think this question is a typical question related to the intervals, how to add a interval, how to merge intervals. So I think by using the upper bound or lower bound is to improve the time complexity from O of n to O of n log m, because the lower bound and upper bound is like binary search. It's not O of n to iterate each element. But I think if you don't use the lower bound or upper bound, it's also okay. You can check each interval and to get to know if it overlap with other intervals and do some extend or delete or remove. I think it's also okay.
Yeah, what I also felt like there are some questions, similar questions, if you see down. It has like merge, insert. So I think what Emily is mentioning, like if you don't do that, you can do, if you know how to merge intervals or insert intervals, still it is doable. But it you might end up traversing all your elements.
Okay. So one just question, like it might be the not right question, but we are already using a map, right? So we are already ordering all of the intervals in some order, right? So do we still, because map I think is almost binary search sort of traversal.
You meant like tree map?
No, even the map in C++, like we have two maps in C++, map and the unordered map, right?
Okay.
They are also internally done with a binary search sort of traversal. So again, yeah. So I was
map in C++ is same like what Sim is mentioning here, the tree map in Java.
Yes, yes.
Yeah, so you don't have to go and search when you say lower bound or upper bound. That is a good one to do it. But when you have to go, you don't have to iterate through each and every, element to find out the whatever the left or right you want. You can directly go to the map and find. So you will get either you will get that element or you will get the end or the beginning, whatever the way you're traversing. So just a quick thought about it.
Yes. But still, I feel like these kind of questions, I don't know if somebody will ask in a real interview or not, because this has a lot of conditions.
And also there are a lot of, corner cases. I was trying it. If you do it, whatever the way it is, you will keep getting a lot of many errors and you have to do it repetitively for a long time. So to get the things right.
Yeah.
Yeah, no problem. So this was a good session, I would say.
Thank you. I'll stop sharing. I will stop recording.